Hi, I'm Alexis, but I go by cute.
Hi, I'm Emmie, but I prefer right.
Hi, I'm Darien, but people call me obtuse.
And
we
are
Health Angles. We're the ones they call when people have problems.
But not just any problems.
Big asymptote problems.
Y equals x plus 4, y equals negative 1, and x equals negative a half. This is one of the biggest problems we've ever had to deal with.
Yeah, normally we only have to deal with one or two. But this time we have three problems to deal with. Right? Give us a rundown on the first equation.
Alright, well for the first one we have a vertical asymptote of negative 1/2. That means when you sub it in on the bottom, it's going to give you a 0.
And it's all fun and games until someone divides by 0.
So for the first one, we're using the vertical asymptote of negative a half, and we know that that will affect the denominator, and when subbed in for x, it'll give us a 0, which creates a vertical asymptote. So to solve this and find our denominator, we wanted to get the equation equal to 0, so we would know what equation would give us negative a half subbed in equal to 0. So we rearranged, and it gave us 2x plus 1, and then we subbed negative a half in, which gave us 0, which is what we were expecting. Okay, for our second asymptote, we're using the oblique asymptote. When we do our long division, it's going to be the quotient, and for our divisor, we're going to use the denominator that we found before. So now we need to find the dividend. First off, we know that the degree of this equation is going to be 2, because we know that n has to be greater than m by 1, and m is 1, so n has to be 2. Next, we had to find the leading coefficient. And it was a little bit different because we're used to having these two and finding the quotient, but this time we had to find the dividend. So we multiplied the 2x and the 4x, which gave us 8x squared, which makes sense because 2x times what gives us 8x squared is 4x. So then we subtracted, and we were given a 4x by multiplying the 1 and the 4x. So in order to get this plus 1, it was 2x times what? So it's going to be 1, which gives us 2x. So to find the 6x, we knew 6x minus 4x is going to give us this 2x. So then we multiplied again. But we knew that there had to be no remainder, or there had to be a remainder, because if it wasn't, this would be a factor of our equation, and it would create a hole, not an oblique asymptote. So we put a 2 in here, which gave us a remainder of 1, so this would work as an oblique asymptote of our equation. So the final equation is 8x squared plus 6x plus 2 over 2x plus 1.
And we ain't no amateurs.
You got that right.
We don't propose a solution unless we're positive.
We're going to show you that the proof is in the pudding.
Okay. Alright, so this is our graph. The red line is our vertical asymptote, the blue is the oblique, and the green is our rational function. So as you can see, this is our rational, and it's slowly coming down and approaching, but
Can't touch this. Can't touch this. You can't touch this.
And that's how you get negative 2x.
Whoa, back it up. How did you get that? So in the previous equation, we already solved for a vertical asymptote, but we're still going to use this as our denominator in order to solve for a horizontal asymptote. So a horizontal asymptote is y equals negative 1. So in this equation, n equals 1 and m equals 1. So since they're the same, we then have to go to the leading coefficients in order to solve. So we already know from the vertical asymptote that our leading coefficient is 2, which is shown under here, but we don't know what our numerator leading coefficient is, so we have to sub in a. And we know that it's equal to negative 1 from our horizontal asymptote. So from this, you simply solve for a, multiplying both sides by 2, and resulting in a equals negative 2. You then know that this is the leading coefficient for the numerator, resulting in negative 2x all over 2x plus 1.
function on the big screen.
Holy shit! Look at that asymptote on that mother function.
So in this one, the purple is our horizontal asymptote, the orange is our vertical asymptote,
and the black is our rational function. So as you can see, the graph approaches the asymptote just as in the last one, but it never touches it. I tackled that last problem so easily, I'm definitely taking on this one. Got an oblique, a horizontal, so 4x plus 1 equals negative 1.
Hold
Right,
on, I don't
'cause-
think so. Isn't it 4x plus 1 divided by negative 1?
No, it's definitely
Whoa,
equals
what are you
negative
guys
b
doing?
Plus or minus the square root.
You're wasting your time. This is impossible. There's a problem with the third problem, and that problem is there is no problem. When you're looking at horizontal asymptotes, we're looking at the degree of the numerator and the degree of the denominator. So if the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote will be at y equals 0. Another way of thinking of this is that if you have a small number on top of a larger number, when you divide them, the numbers will get closer to 0 but never equal it. Then, when the n value is equal to the m value, you look at the leading coefficients of n and the leading coefficients of m. Then your horizontal asymptote will be the answer. But what we're interested in is when n is greater than m. When n is greater than m, there is no horizontal asymptote. But if n is greater than m by 1, there may be an oblique asymptote. Another way of thinking of this is that if you have a large number over top of a small number, there will be no trend and they will never approach 0. So, in this case, you can have a horizontal asymptote or an oblique asymptote, but not both.
How's angles? Acute speaking. Oh, wow. Okay, yes, we'll be right there. Guys, we got a 4-1-1. 2 holes and a vertical asymptote. It's time to common factor. Holy! Hell's angles, roll out.
To infinity and beyond. I meant positive infinity.
Right!